Hi, my name is Sharon Praveen. This is tech demo number 1. We are first asked to plot this line given here. The way we can do this is by creating a point in Desmos with one variable, and with this addition we can multiply t into the first vector and add the second vector, so that would look like t plus 10, t, and t. And even though it's a point, we can range t to be almost negative infinity to infinity, but I'm just going to do negative 100 to 100 to simulate infinity. And we are given our line here. The 1, 1, 1 is our direction vector, and 10, 0, 0 is our vector we get when t equals 0. So it is our x-intercept, and this is our infinitely long line. Next, we are asked to plot this equation given here, and to do this we can just stick this equation into Desmos. 2x plus y minus 2z equals 2, and this gives us a plane, and this plane is all the points which are solutions to this equation. Also, we can subtract 2 and factor it out and find the normal vector for our plane is 2, 1, negative 2, and that gives us extra information about the plane. Another thing we could do is algebraically manipulate this. X plus 1 half y minus 1 equals z, and this gives us the same plane in terms of z, which will help us later. Next, we are asked to plot another graph, x squared plus y squared equals 3, and again we could stick this into Desmos. X squared plus y squared equals 3, and this is the graph of a circle with radius square root 3 on the xy plane. Since we are in 3 dimensions, we can extend this to 3D, and this extends it in the z-axis infinitely long because there are no constraints on the z values. So this is an infinitely long cylinder. Next, we are asked to plot the intersection between our original plane, I'll do a different color, our original plane and the cylinder we created. And since the plane intersects the cylinder at an angle, we know that the intersection will be an ellipse, not a circle. So we are asked to plot the intersection. To do this, we can begin by keeping our x and y the same as in the cylinder. So we can do parametric form, so we could do cosine t, sine t for the x, y values, and we know that the radius is square root 3, so we can multiply this by square root 3 to give us a circle of radius 3 in the x and y values. And for our z value, when we made our equal equation for the plane, it gives us z in terms of x and y, so we can put our parameters into that equation. So our square root 3 cosine t goes into our x value here. Square root 3 cosine t. And our square root 3 sine t can go into our y value. Plus 1 half square root 3 sine t. And then minus 1, and that should give us our z value in our parameter. And this is the equation for the intersection between the plane and the cylinder. Notice it's only a fraction, so we can set our t to go from 0 to 2 pi. And this will fill out our cosine and sine and all our trig to create a full loop all the way around. We could do even more higher parameters for this, but 0 to 2 pi is all we need to create one full loop. And this gives us the intersection between the cylinder and the plane. We can see this without the cylinder and the plane now. And this is our graph for the ellipse.